Hi, everyone. My name is David Levine, a member of the AIA Building Science Committee and architect at Datner Architects. The Building Science Committee is chaired by Nassim Narouzi, an associate principal and facade consultant at Arab. We encourage you to visit our homepage and the committee subpage at AIANYork.org to read about our mission and view recordings of past events. We are always looking for volunteers to join our core committee team that meets monthly to deliver the committee's mission and goals. Please reach out to us through our general committee email address if you would like to, which is b.sci, that's SCI at AIANYork.org. We'd also like to thank the AIA New York chapter for their hard work on producing this webinar. So for today's webinar, we have with us Stephen Gaynor, who is a principal consultant at Pivot Corporation, and we appreciate his time and expertise today. Stephen serves as a vice chairperson on the board of directors at the Rainscreen Association of North America and is a voting member on the ASTM Committee E06, establishing standards for the performance of buildings. Stephen specializes in commercial facade product market entry and growth strategies, as well as certification and compliance management. Stephen will speak to us today about the new and amended fire blocking requirements in the 2022 New York City Building Code, which are affecting the way we design and detail and build rain screens here in New York City. So Stephen will go through his talk, and then hopefully we'll have about 10 minutes at the end for a Q&A. Please post any questions you have in the Zoom link in the Q&A function only. We would like to use the chat function for links that the AIA team will post, including the fact that this event will provide one health, safety, and welfare, CEU. So when that link is posted, please fill that out to receive credit. And with that, Stephen, please take it away.
Thank you, David. I'd like to thank AIA New York and the Building Science Committee, as well as Nassim, Salmata, and Philip for putting this together. So yeah, what we're going to be talking about today is the 2022 New York City Building Code. We're going to go through a bunch of language for there on rain screen fire blocking and the major changes there. So let's get into this. As far as the topics, I think it's helpful for us to start with some ground rules and a refresher on some basics behind fire compliance and testing. And then, we'll get into the meat of the history of these code sections. What is the fire blocking language? Then we're going to look at some exterior cavity details. What does it look like to do that kind of fire blocking? And a few sort of updates with what's been going on with the Department of Buildings and some conversations around this sort of fire blocking language. To start with, I like to provide these spoilers, mostly so that we can hit on some important points and then we can remember them, but also if you want to fall asleep after this because you're not interested in actually getting into the details, you have everything you need on this first slide. So let's just go through these real quick. What we're going to be talking about today is fire blocking is required in the exterior wall covering, and we'll talk about the exterior wall covering in a second. Fire blocking is even required with many non-combustible cladding assemblies, and that's I think something that's well misunderstood. We'll get into the language there. Fire blocking placement rules are different for assemblies that use non-combustible components versus assemblies that use combustible components. There's two sets of rules, and we'll break those down. All products that require NFPA 285 will now be required to test an assembly using fire blocking, and new NFPA 285 language restricts many of the previously accepted combustibles. We will review that language at the end of the presentation. And then, architects manufacturers and architects should prepare to submit actual reports for inspection. And what I think is one of the most major changes from a ideological standpoint is architects are now responsible to approve any changes from the NFPA 285 test assembly and certify that any on-site changes will not fail. Right? That's, I think, something at the end of this presentation that might draw a few questions. So there you go. If you're not interested in the details, you have all the important points. Now let's start with the ground rules that I always like to review before we get into any code language, because for folks that aren't in code language every day, like myself, I think it's often misunderstood how how code is actually both written and enforced. Rule number one for me is that code logic doesn't exist. You have to suspend your sort of your typical logic streams and realize that the code language is what it is. Rule number two is that this should be a no judgment zone. I spent the first couple of years dealing with this language, getting frustrated. And what we should all recognize is that new building codes, especially ones that change this much and try to advance this much, are always going to have conflicts and gaps and areas of confusion. We hopefully will be able to have some clarification and adjustments going forward, but it's something that we have to live with in order for code changes to occur. And then rule number three, building code language does not equal project compliance. And project compliance is a mixture of both the AHJ enforcement in individual jurisdictions and code language. So even though we're going to be reviewing a lot of code language today, what we're talking about and what the code language actually says is also mixed with who's enforcing it and project specific requirements. And that really gets into our disclaimer here, is that we're going to be talking about certain code language. I'm going to be voicing certain interpretations of that code language, but how it has to applies to your specific project is going to differ, right? And that's going to be because of a lot of reasons, not just because of your project and the AHJ enforcement. From that perspective, any use of this sort of information on a specific project should be done by a professional. Now let's review some basics here. On the right-hand side of your screen, you see a section view of a typical detail for a Rainscreen assembly. You see what is a concrete slab there, and then depicting a stud wall on the top and bottom of that. Then you see a Rainscreen assembly on the outside of it. It's important for us to review some basic terminology, not only because we use different terminology, but the code often will use different terminology talking about the same things, or the same terminology talking about different things. So when we're talking about exterior cladding, you see the dark green on your screen here. That's the outermost layer. It's also known as exterior wall covering, or architectural trim in the code language. So remember that. Exterior cavity might be known as the cavity, the airspace, the concealed space, or just the space. And this is when we talk about the exterior cavity or the cavity, we're talking about the cavity behind the exterior cladding and in front of whatever the next layer is. Maybe that's exterior insulation, what have you, but that's the exterior cavity we're talking about. Cladding attachment is also known as substructure, attachment system, framing, or components, or framing system. And exterior insulation, if for the code language, we might see continuous insulation or something like that, but we often talk about exterior insulation referring to rigid insulation or the CI layer. And then finally, the water resistive barrier. In the code, that's pretty consistent, but this barrier might also be interchanged with the air barrier or the water control layer. Together, this whole assembly is known as an exterior assembly, a facade system, or exterior wall covering. And that's another important point. Exterior wall covering in the code might be referring to just the exterior cladding or the entire assembly. Another quick point of review is NFPA 285. If you are not familiar with NFPA 285, then you should probably take a primer course before getting into the language we're going to talk about today. But I just want to talk about a couple of things. On the right-hand side of your screen, you see a section view of what is the NFPA 285 test. And this is a test that determines flame propagation and heat propagation up a wall system. What we want to do by implementing this test is make sure that the exterior wall covering does not propagate flame or heat in a way that spreads it up the building or to separate units. The test parameters for that are fairly simple, and the important ones, I think, for our discussion are that 10 feet above that window opening where the fire is occurring, and 5 feet from either side of that window opening. During the test, you cannot exceed 1,000 degrees in those locations, and the flame can't be attached in those locations, essentially meaning the flame is limited and the heat is limited. Now, what's important about that is this test traditionally has been used for any sort of combustible materials, right? And that's because the fire doesn't care what it burns. I was taught that very early in my career, and as far as enforcement goes, right, rule number 3, we've seen that AHJs have usually accepted NFPA tests, NFPA 285 tests for materials that aren't mentioned in the code because it's all about the performance, right? That flame spread and the heat development. And traditionally, these are for material. This test is for materials that are categorized as combustible per ASTM E1 through 6 or that section in the code. Just a quick note, running a test like NFPA 285 takes a bit of time, as you might imagine. Building a 2-story wall, getting everything together, drawings, etc. It takes about 4 to 6 months of planning and then a week on site building and running this test. It could take upwards of $50,000, even to $100,000, depending on what you're testing for each test. So this is not something that's very flexible in terms of, just running a test per project or for different changes on a project. Now we get into the codes themselves, and I think the first thing we want to remember is that New York City sort of has a tradition of not necessarily aligning with the rest of the country with for building codes. Up until 2008, New York City had their own building code, and then in 2008, New York City decided that they wanted to align with the IBC and adopted their modified version of the IBC 2003. Now, what happens here is that New York City assembles a technical committee. I actually serve on that technical committee now for the next code review, but they assemble a technical committee reviewing whatever IBC language they're looking to adopt, and then modifying that and proposing those modifications to the city council for adoption. So again, in 2008, New York City adopted their version of the IBC 2003. Now, as we get into the language we're talking about, we're going to be talking about a couple different versions of code, right? So before the 2022 language came into place, we had New York City had the 2024 New York City construction codes or New York City building code. That was aligned with the IBC 2009. And what's important there is as we look at what those changes were for the IBC between 2009 and 2015, we see why New York City may have started to look at these sections and said, hey, we need to take a look at this and decide what's best for us. So let's talk a little bit about the fire blocking language in the IBC. In 2009, and actually New York City's 2014 code, there was a fire blocking section in the IBC, and that section basically said all of these exterior wall coverings needed to be fire blocking in that exterior cavity, and then provided some exceptions. We'll talk about that in a second. But when we think about rule number 3 in terms of building codes, we think about enforcement is just as much a part of this as the language. And across the country, AHJs in different jurisdictions were accepting NFPA 285 assemblies that didn't have fire blocking as an acceptable assembly to put up without fire blocking, and as an exception to this rule, so long as it was put up with that fire blocking, with that NFPA 285 assembly that matched the test. And you can imagine, if we think back to the NFPA 285, the fire doesn't care what it burns. We're looking at performance, actual flame performance and heat performance. And so building officials didn't want to mess with that. So in 2012, the IBC adopted an exception to the fire blocking language, and that exception is at the bottom of your screen there. It says, fire blocking shall not be required where exterior wall covering has been tested in accordance with and complies with the acceptance criteria of NFPA 285. That exterior wall covering shall be installed as tested in accordance with NFPA 285. Again, if you have an NFPA 285, it doesn't have fire blocking, put it up as you tested it, because we know the performance of that. That was codified into the code because everyone was using this policy outside of the code before that. Now, 2015 had the same language in it, and also and then you can see that 2014 matched the 2009 language without that that NFPA 285 exception. Now, looking at that 2014 section for architectural trim, which is the section that applied to exterior wall covering, we see that the changes were pretty vast from 2014 in New York City to 2022 in New York City, right? And on the right-hand side of your screen, you're seeing that section, what that section turned into in 2022, and really the basis of our discussion today. The other part that changed significantly is the 285 sections. In 2009, the sections that required NFPA 285 were really isolated to the MCM section of the code and then the foam plastic. And that's not to say that this was the only place where NFPA 285 was used. In fact, just again, thinking about rule number 3, that language is just as important as enforcement. The way that this is enforced around the country, and actually even in New York City prior to the new code language, we were looking at AHJ saying, we can use the NFPA 285 for anything that's combustible, not just MCM and foam plastic. And then IBC codified that again into the code. Now, for New York City, we look at these 2 sections that were in 2014 that mentioned 285, and then we look at the 285 section that was added for the 2022 code. This both match some of the language that IBC put in there, but also had significant changes about materiality that we need to talk about in a bit. Now, both of these changes together, when I talk about the fire blocking changes and the NFPA 285 changes, affected 113 sections of the code. And that's really where we get into why we're talking about this today, because it has a wide effect on many different parts of the building code. Now let's get into that language. So the language states, and we're seeing 718.2.6 architectural trim. The first thing you see there, it says fire blocking shall be installed within concealed spaces of exterior wall covering. So if you were thinking architectural trims isn't wall covering, it says right there, exterior wall covering, and other architectural elements permitted to be of combustible construction as specified in 1406, where erected with combustible frames and a maximum of 20 square feet. There will be no, a maximum of 20 linear feet, and there will be no open spaces exceeding 100 square feet. So essentially what that means is that we are putting together compartments within the exterior wall covering that are 100 square feet and no longer than 20 in any direction. So the maximum length you could have is 20 by 5, and that gives you 100 square feet. Skipping down to the end of this this language, and you'll notice if you've read this language that I'm actually using the proposed language, because the proposed language gives us a very good view as to what was taken out, what was added and changed, etc., by using underlines and cross-throughs, etc. So you might have a little bit different from an editorial standpoint, looking at the actual code, but this is the content of language is the same. So looking at the end of this section, you see, for the purposes of this section, fenestration products and flashing of fenestration products and water-resistant barrier flashing and accessories at other locations, including through-wall flashings and attachment accessories, shall not be considered combustible construction. What's left out of there, and what the NFPA 285 section does address that New York City decided not to put in this section, is the water-resistant barrier themselves. So effectively, this says that the water-resistant barrier is one of the triggers for fire blocking, even if you don't have any other combustibles in there. Now we look at these exceptions for the New York City fire blocking, or New York City code in 2022. And the first thing we see is they chose not to adopt the NFPA 285 exception in the IBC. So that means that having NFPA 285 does not exempt you from these fire blocking requirements. The second thing is we start to see exceptions where the cladding is called out as having exceptions for not having to use fire blocking, as long as you're using non-combustible framing, right, non-combustible substructure, and no plastic or foam plastic insulation. So you see aluminum cladding and steel cladding. These are plate aluminum, plate steel, as long as you're using non-combustible framing and non-combustible insulation. you do not need to put fire blocking in there. Very interesting, as we move down to 2.3 here, you see that they've crossed out and eliminated other approved non-combustible materials, right? And this was very deliberate. The DOB has made this clear to me that this was very deliberate, that that they wanted to specifically list the materials that had an exception, and they didn't want the combustibility test to be that exception. So that's where we see that non-combustible materials sometimes also trigger fire blocking because they are not listed in the exception for non-combustible materials. I'm not going to get into this language, but the language is pretty clear, and the DOB has been pretty clear on that point. What I do want to do is get into the language for the exceptions of non-combustible materials that do not need fire blocking, as long as you're building with non-combustible framing and non-combustible insulation, and the water-resistant barrier is the only combustible component, right? So 2.3 was replaced with brick, concrete, stone, terracotta, stucco, or steel cladding with minimum thicknesses according to the table in 1405.2. And I don't know about you, but I can think of a lot of other non-combustible materials that are not listed in there that now apparently, and this has been confirmed, trigger the fire blocking requirement. Now, even for those non-combustible materials listed, we go to table 1405.2, and we see that you have to use thicknesses that are mentioned there in order to avoid the fire blocking requirement. So, you know, thin brick, if you're using any thin brick that's less than 2.6 inches, you then have this fire blocking requirement. Concrete thickness is not listed in this table, even though that's one of the requirements. Natural stone, it has to be at least 2 inches thick. I was just working on a project where they have 1 1/4 inch limestone. So, you know, in my reading of this, that would mean that the fire blocking requirement's triggered. And you see the other ones here. Terracotta, it needs to be at least 1 inch thick. If you're using a flat terracotta that's 1/2 inch thick, that does not have the exception. Then you look at other non-combustibles. You look at porcelains, right? Porcelains are made at above the temperature for the non-combustibility test, and they are still not part of the exception, right? And that's where we start to look at rule number 1 again. We say suspend your typical logic streams. We don't have typical logic streams in the building code. We have to work with the language. So you look at porcelain, you look at terracotta under 1 inch, you look at non-combustible fiber cements, UHPC material, GFRC material, and others, all still triggering the fire blocking per this language. Moving on, so you know that's an important point. Keep that in your brain, that those non-combustible materials still trigger fire blocking, right? And that's where you get the first rule of fire blocking, those 100 square foot compartments that are listed in the main section up there. Now we move on to exception number 3 in the 2022 New York City Building Code. And this exception essentially says if you're using combustible materials like HPL, MCM, and plastics, then we have a different set of rules, right? So it says this is an exception. You do not pay attention to the rules in 718.2.6. You pay attention to the rules in 718.2.6.1. And what that means is if you have these materials, you have to have fire blocking around wall openings, around at every slab edge for a minimum of 8 inches of height, and where the occupancy changes. For those of you who are paying attention, you see that a minimum of 8 inches height is the first time we've seen any requirement in terms of the thickness of fire blocking, right? There are requirements for the types of materials that qualify, but not the thickness. And so this is the first time we see 8 inches. If you're using combustible materials, you have to put 8 inches at the slab. We don't know what that is for the other fire blocking requirements. The DOB has not been clear about that. The language is not clear about that. That's something that has to be worked through. Now, as we look at foam plastic insulation, we have essentially the same rules for foam plastic around all wall openings, at the slab for 8 inches, and when the occupancy changes. What's important to note here is that it's very clear that foam plastic needs to be interrupted with non-combustible materials in order for the fire blocking rules to comply. So you need to stop and start your foam plastic. Now, there are other exceptions where you don't need fire blocking for foam plastic up to 75 feet if you have very specific conditions. If you have concrete or masonry completely encapsulating that foam plastic up to 75 feet, and you're on a concrete backup wall, right? So no studs, etc. Then you have you don't need to put fire blocking for that for that application. The same thing for exterior insulation finish system on a fully concrete backup wall, and the insulation is fully encapsulated. Not going to get into the one-story exception. New York City is unique in that it has both a commercial and residential code sort of combined into one. And then, I do want to get into the NFPA 285 language for just a bit. The NFPA 285 language states, rather than what the IBC did in this time period going from 2009 to 2015, the IBC said, okay, we've been using NFPA 285 for all combustible materials because we only care how the building performs or how the wall performs, and 285 helps us determine how the wall performs. So we're going to expand that basically and say, we can use NFPA 285 for all combustible materials. The New York City Building Code has gone the other direction and said, we're going to take this NFPA 285 language and we're going to say specific materials shall be tested to NFPA 285, and that's foam plastic, metal composite materials, high pressure laminates, and fiber reinforced polymer. And then the rest of the materials are sort of left out in no man's land. So there's other combustibles that are not mentioned in here, right? And you can think of a ton of other combustibles. What happens with those other combustibles? That's essentially we're relegated to the section that limits combustibles to about 10% of the exterior wall area, and has other limitations in terms of height and separation distance that I'm not going to get into here today because I want to talk about fire blocking. But you should know that that's one of the sort of open questions of the new code. Now let's get back into fire blocking and look at what these implications are. Now, I know there's a lot of architects on this call, so forgive me for my rudimentary PowerPoint sketch here. But what I wanted to do is give an example of, if I'm looking at a 4-story building, I didn't put any openings in there, but I'm using the non-combustible component requirements, saying, okay, I have to make 100 square foot compartments. I'm going to assume my slabs are about 12 feet apart, which means that my verticals then have to be 8.5 in order to meet that 100 square foot. So here's my fire blocking layout on this wall in yellow. Now, what does that mean? When I want to put up a Rainscreen system, I have to think about drainage and ventilation, right? And that exterior cavity has a whole lot to do with the drainage and ventilation for my Rainscreen system. So I want to maintain my Rainscreen wherever I can. So I'm going to put up a row of panels between my fire blocking, right? And that's the way I'm going to maintain my Rainscreen system, is have an opening above and below that fire blocking so that I can still maintain some amount of drainage ventilation. And so I'm going to put my panels up like that. And then I want to limit the fire blocking where the fire blocking is going to really affect my drainage ventilation, the performance of my wall. And so I'm going to put all these little panels directly over whatever the height of my fire blocking is. And there's my my wall assembly. Now, what does this look like when we're talking about water management, airflow, thermal performance? Well, let's look at this detail. Again, on the right-hand side of your screen, you're seeing a section detail of what that wall system might look like. You see that slab, you see the stud wall above and below that. You see exterior insulation. I've eliminated all the components in here just to make it a little bit easier, and then shown the cladding with the cavity. The first thing you see is that exterior fire blocking. Again, if we're using the non-combustible rules, we don't know what that fire blocking at the slab needs to be in terms of height. If it's combustible, then you have 8 inches. For non-combustible, we don't know what that is, but it's some amount. And so let's look at what the performance of that wall is. Well, if we're using mineral wool, and I'll tell you why in a moment, mineral wool at this point is the only sort of reasonable explanation or reasonable material that we can assume there. If we're using mineral wool, we might get some drainage through that mineral wool, but over time we're going to have dirt and silt and leaves and other things in that cavity that plug it up, and we're not going to have any sort of control over the water management at that area. So, looking at mineral wool from the other angle, from the airflow angle, we are definitely going to be blocking the airflow through the cavity, and so, inherently these sort of fire blocking requirements conflict with our typical water and air management designs that we use on buildings. So what do we do? The first thing I would think is we put metal flashing in there, but you can't put metal flashing, over the face of your insulation and feel good about it. So we're going to get water behind there, and then you're going to get someplace that never dries out, and who knows what happens with that water. So then you're looking at through wall flashing, but then you run into your thermal performance. What happens when you put continuous thermal bridges every place you have a horizontal fire blocking, right? And so this isn't only at the slabs, it's around openings, it's everywhere we're going to need fire blocking. That's, what is the degradation of your insulation if you're doing that around your building? So, the next question is membrane flashing. Well, we are attaching over a number of different materials that are moving in a number of different ways and may or may not be able to stick to membrane flashing. I think that that's just not an application that membrane flashing is made for. And so I think we have to stick with that, with that idea that we would have to flash with a rigid flashing. Now you might say metal is non-combustible, so why don't we just make steel fire blocking all across the building? Steel is, the fire is not going to go through steel. We can then put a bigger joint above and below that steel, and we maintain our airspace and drainage, etc. Now, that's a good thought. Steel is not one of the approved fire blocking materials, and there's good reason for that. Depending on your assembly, steel is not going to prevent the heat from transferring, and that's if you have combustible materials adjacent to that steel, you may also have a dangerous situation with fire on one side of that. So then we get into other solutions, and I will tell you right now, we don't have a good solution for maintaining airflow and drainage that is approved by either New York City or any other AHJ right now in the U.S. We do have good solutions outside of the U.S. that are approved, tested, and have performed over time, like intumescence. Now, full disclosure, I have a client that I'm helping through the New York City approval process with an intumescent fire blocking, and hopefully that will give us some path forward in terms of being able to maintain both drainage and insulation and meet your fire blocking requirements. For those of you who don't know what intumescents do, essentially they expand when they're exposed to heat. So you can put a small strip of intumescent into a cavity and then maintain airflow and drainage. Now, when you have a fire event and that heat hits the intumescent, it effectively blocks that entire cavity, expands the entire cavity, and creates the compartmentalization we want during that fire event. Now, this has been tested over and over again. The first test I specifically did with intumescent was back in 2008 when I was dealing with fire compliance issues, and I found that that it effectively satisfied the requirements that we had back then. But again, in the U.S., we don't have a lot of AHJs that are looking at these sort of solutions. Now, for the combustible component rules, I just want to hit on it again that we don't know what those fire blocking depths are or heights are, other than at the edge of the slab. But what I want to do is take a look at what it looks like from a combustible component standpoint. So I live in New York City, which means I effectively live in one room for my entire life, and this is essentially the outside of my apartment in my building, which is 12 stories. And I've put a you see the two windows there. I've put what maybe an MCM or some sort of combustible material, HPL, something like that on the outside. Then we have to go with the fire blocking requirements for MCM or HPL, which means that we're going to have to go around the windows and at the slab, right? So what does that mean around the windows? Well, essentially, it means that we have to create a compartment around that window and also avoid all of the other components in there, meaning that you probably can't put it directly around the window. You're probably going to have to work your way around, attachment components, etc. Then you need to put some sort of water management solution back there. And this is everything you have behind your wall system, right? So, while it's not the the greatest in terms of what you want to do, effectively that's what's required. Now, looking at those materials, I talked about the fact that mineral wool is the best solution here. I think the reason why is because here are your material lists, and what you see is there are some materials that can go outside, right? So this is the fire blocking material list for every place you need fire blocking in the wall system. There are some materials that can go outside, but these are not materials that can easily go around things like substructure components and all the ins and outs of what happens in that cavity. So if you're talking about gypsum board or cement board, etc., yes, they are fire blocking materials. Effectively, they are unusable outside of in this application. So you're looking at number 7 for mineral wool or something like that. And then what New York City did do is they added number 8, which is other materials approved by the commissioner. I think that's an acknowledgement, and what I've been told from folks at the DOB is that's an acknowledgement saying we are going to need to look at other solutions for certain situations. Just hitting on this real quick, if you're doing the NFPA 285 test, you are going to need to have fire blocking in that test. You will not, judgments will not be accepted that say we have an NFPA 285 test and fire blocking. If you add it to fire blocking, it'll perform the same. Those judgments will not be accepted in New York City, so you have to retest if you do not have NFPA 285 or fire blocking in your NFPA 285. Also, special inspection will now include your NFPA 285 assemblies and your reports to make sure that the details that are on the wall system are matching your 285 assembly. And that does include the fire blocking details. And then, I said I was going to get to it. This is really where the architect and registered design professional get into more liability than they had in 2014. Essentially, what this says is that the registered design professional shall approve the NFPA 285 tested design. But then it goes further, and if you look at number 3 here, it says a certification by the applicant that any deviation which occurs during the course of installation will be evaluated and approved by the applicant of record or registered design professional. No deviation shall be approved that would result in an assembly that would otherwise fail to pass the acceptance criteria of NFPA 285. Now, to me, that's a pretty high bar. I don't know, if I could sign something like that, but this is what's required in the code. Now, getting away from the code here, key takeaways are, that achieving high performance building closures has become a little more difficult. Designers and engineers have to work harder to find innovative ways to meet competing goals. Environmental goals like Local Law 97 become more difficult to achieve while trying to meet other compliance requirements. And then increased interruptions in the wall covering assembly and more paths for air leakage and water leakage, have to occur from us having to add these different methods for not only fire blocking but also protecting our walls. And I feel strongly that implications and confusion created by the language could potentially have negative effects on the whole community. And that's coming from a place where luckily I was able to work for folks for manufacturers that did it right, but I come from the manufacturing side of the business, and I know all the sort of the tricks of the trade and things that happen either intentionally or unintentionally with these things. So that kind of those sort of gray areas are definitely concerning to me. Now, green shoots, this is where I think we could talk about some positives. The DOB is aware that items need to be addressed. An approval process does exist now. I spent the last 2 years of my life trying to sort of get my way through that. And then a new code review committee is assembled. And, just in terms of knowing that things need to be addressed, the DOB has already put out one bulletin. I've heard rumblings that there's a second bulletin, in the works for clarification on these items. For those of you who know the language and are familiar with building code language, you'll know that the bulletin really doesn't go beyond the language, but it does clarify in a little more plain language what the DOB intends. And then there is a review process that that now I have sent, or my company has sent three products through, and those are non-combustible products that need this review, right? So I'm proud to say that three clients of mine, Porcelanosa, Swiss Pearl, and Equitone have sent their non-combustible panel systems through this and have achieved an acceptance for being able to be used like those materials in exception 2.3, right? So as long as they're being put up with no other combustible materials except for the water-resistant barrier, they do not need fire blocking. The DOB has been very clear that that not only do these materials need to be reviewed, but individual products from individual manufacturers need to be reviewed. In all of these letters, it says it does not apply to other materials in the same segment, only applies to the individual products. Now, if you're going to do this, be careful. The DOB and FDNY will not figure it out for you. They are not there to do that for you. It's your job to make a well-informed, well-verified case for acceptance. And I'm not preaching to you. What I'm doing is telling you what I've experienced. The FDNY is also now a formal part of this review process. So you go through two review processes, one with the DOB, one with the FDNY, to get your approval. And then rejections can have implications on future submittals. There is a box that says, has this been submitted before? And so, you really want to avoid appeals. And then New York City Code review for the next cycle. Like I said, there is a technical committee in place right now for reviewing the code language for the next cycle. We are reviewing the 2021 IBC language for adoption in the next round of New York City code, building code language. Some restrictions do exist for addressing mediated items. That's not specific to this round. That's just a policy for the DOB saying, items that were mediated in the last round cannot be changed in this next round. But it doesn't mean we can't put clarifications in there and make this a little bit easier to understand in terms of figuring out compliance. It's also virtual for the first time, and the intent of that was not the pandemic, but was to expand the pool of contributors. So what do we do for now? For now, we live within the code. We continue to work on compliance clarification, and we look towards industry leaders like my clients and other folks I know in the industry that are submitting both general approvals and project approvals to see where we can clarify some things that are not clear in the code. The initial indications from the DOB feedback is that, or the initial indications from the feedback we've gotten is that there is a broader understanding of these new requirements spreading within the DOB. I've seen now some back and forth from different areas of the DOB where they are explaining this. It's clear that all polymer and FRP components will be considered a trigger for fire blocking, at least as far as the DOB goes. And then every individual product will need their own approval if they're not specifically listed in the few exceptions in the code. Now, my thoughts are, New York City could have and probably should have done better with the fire blocking requirements. However, there are many parts of this code that are positive advancement, and I think the increased focus on transparency of compliance documentation and making sure that things are built that way is the most effective way to have safe buildings. If we were doing that across the rest of the country, I think there'd be less concern about where this fire performance stands. And for me, ensuring that designs match testing and buildings match designs will help us all build better. Thank you. I hope this was useful. David, do you want to pull up the questions?
Hi, Stephen. Yeah, I am looking at our Q&A and I don't see any.
Everyone's asleep.
Everyone you did such an excellent job of presenting that there weren't any. So I'll see if they feed in. As they feed in, I guess I can ask you a few. First of all, thank you very much, Stephen, for that excellent presentation. Just getting back to the original diagram that you did, if you have non-combustible construction, you will still be that 100 square foot rule, so to speak, is that you're saying that we will have to fire block at slab edges, we know that, and at slab edges, we're going to be at 8 inches. But that we also have to form areas no greater than 100 square feet. Is that correct?
So yeah, so if you're using non-combustible cladding, insulation, and framing, the WRB is still a trigger for the fire blocking. Depending on the requirement or the performance of the WRB, it may not be a trigger for NFPA 285, but it's still a trigger for fire blocking. And in that case, where you're using non-combustible insulation, framing, and cladding, you have that 100 square foot compartment.
Okay.
And so it doesn't need to be at the slab, but this drawing just sort of makes it simple in terms of trying to translate that design to your panels.
Okay, thank you. All right, we do have a few more questions coming in that I'll share. Someone asked, is this code retroactive? I'm assuming for projects filed under the previous code. I'm assuming the answer is no.
The answer is no. The code is not retroactive. The code was voted in on November 7th, 2021, and came into effect on November 7th of 2022. So anything that was permitted after 2022, this definitely applies to. I don't fully understand the process of sort of the back and forth of the permitting process. So there might be some gray area of things that were submitted over that span.
Okay. We have another question that asks, what would you say is the general timeline for product getting approval, similar to what your company did for Porcelanosa or Equitone or Swiss Pearl?
So my experience is that because you have the DOB process, and that takes a bit of documentation assembly and a bit of back and forth, and then you have the FDNY process, which is the same thing. My experience has been about 8 months from the application being submitted to getting that letter.
Okay. Thank you. Another question is, will this presentation be sent out? And the answer to that is that the AIA Building Science Committee will have this video posted in a couple of weeks, so everyone will have access to it. Another question asks, given that smoke and fire typically spread from windows, do we need to fire block at window openings and slab edges too? And I think you clarified the answer is yes for that.
So for when you're using combustible components, fire block is required, and you have to remember that if you're familiar with fire blocking on other parts of the building where you actually have rated wall assemblies and you have enclosed spaces that are rated on either side, or joints between floors and things like that, that is a different scenario than with cladding that will likely is likely not rated and will burn away during that time period. And I say that to say that this is a different mindset in terms of what we're trying to do, and what we're really trying to do is slow down the progression of fire when you put fire blocking in there. On the exterior of the building, smoke is unfortunately not something that we can really control.
Okay. Another question came in, are porcelain panels considered combustible? And I guess that goes back to the table, or?
Right. So, so they're not considered combustible, but they are considered to be a trigger for fire blocking, right? And so you might have porcelain panels. A lot of the porcelain manufacturers will put an adhesive mesh on the back of the porcelain for safety reasons, right? So as almost an insurance policy. From that perspective, you have the ASTM E136 test and the ASTM E84 test to qualify as both a non-combustible that's coated. So that would be the same as your gypsum drywall, that's coated with paper face, or if you have a painted material. Again, those things are considered non-combustible, even though they might have a combustible coating.
Okay, thank you. Another question is, can you control the expansion, width, or force in activated fire blocking? What if the activated fire block expands greater than the cavity, pushing the cladding out and thereby negates the fire blocking performance? That's a good question.
Yeah, that is a good question. I would say the intumescents don't have that kind of pushing power, but there might be other solutions in terms of activated fire blocking that that would be that could be the case.
Okay, so the manufacturers of that product have taken that into consideration. So this is another question that it actually goes back to what I asked a few moments ago. Aren't most water resistive barriers considered non-combustible? And then I guess if we do spec one that's non-combustible, and we have the suitable exterior cladding and we have the suitable non-combustible insulation, do we still need to fire block?
So I don't know of a membrane that's considered non-combustible in terms of the ASTM E136 test. There are ways to make your wall system water resistant without using a water resistant barrier, but without using a membrane. But I rarely see that. So go ahead.
So you're saying that normally architects spec a WRB based on 285 compliance, NFPA 285 compliance, but you just said that now we also have to use ASTM 136, and that's where we're getting into trouble?
Well, that's the ASTM E136 is the test in the IBC that determines the combustibility of products. So if you pass that test, then you are considered non-combustible. If you don't pass that test, there's not really a combustible rating, but if you pass that test, you're considered non-combustible.
So you're saying that some of the commonly liquid applied air and vapor barriers that we spec have not passed the ASTM E136?
I would imagine that almost any membrane you're using doesn't pass that test, but it may qualify for the exception in the NFPA 285 language, which says if you have a limited amount of combustibility per other tests, then you don't trigger NFPA 285. Now that language is not in the fire blocking language, and therefore it doesn't apply to the fire blocking trigger, right? It only applies to the NFPA 285 trigger.
Okay. There's another question. Sorry if this was covered. Is there an exception related to the height of the building? And yes, you did clarify that for construction, 75 feet or below. Well, why don't you answer that?
Right. So actually, that's one of the changes that New York City made, is that everything down to grade, both the NFPA 285 language applies to and the fire blocking language applies to. Now, there is a very limited exception for using foam plastic when it's fully encapsulated by masonry on both the outside and a masonry wall system, right? Not a stud wall system. And it's fully encapsulated at all openings, et cetera, where you can use that up to 75 feet without fire blocking. But that's a very specific situation, and I would look very carefully at that.
Okay, thanks for that. Another question came in. Do you have any commentary on glass Rainscreen panels?
Yeah, I mean, glass is one of those things that wasn't listed in 2.3, right? And so I would say that it triggers the fire blocking requirement because it's not specifically listed in exception 2.3 where you have those other materials listed. Just like porcelain or just like other non-combustibles that weren't listed there, they trigger the fire blocking requirement. And again, I don't know exactly how this is going to be enforced on every project, but I can tell you from the conversations I've had with the DOB for the non-combustibles that we've submitted to be included in that exception, they are looking at this all the same way.
Okay. Another participant asked the timeline for the intumescent product availability.
Yeah, I mean, that product's available right now, and it's being specified on projects right now. There is a way to submit project-specific details if you have a project that that could use that. Like I said, it's been used in the rest of the world for a few decades. It's tested, it's certified outside of the U.S. We just don't have that in the U.S. right now. So as far as availability, it's available. The question of when the generic approval letter will come through, it's anybody's guess. We're dealing with the DOB and FDNY right now.
Okay. We're almost out of time. I'll keep going here. another attendee asks, per the DOB, exception number 3 to 718.2.6 removes 100 square foot for exterior wall assemblies with MCM, high pressure laminate, and foam plastics, etc. The exception for the 100 square feet is accounted for in more specific requirements of 718.261 and 718.262.
Right. So that goes to the two separate rules, right? There's the 100 square foot requirements, which are when you're not using HPL, MCM plastics or foam plastics, and then you have the other rules that are at the slab and then around the windows and occupancy types. When you are using those sort of combustible materials, you don't need to have the 100 square foot compartments when you're using those combustible materials.
Okay. Okay, thank you. And then Eric Banks asked, please put up the slide regarding the product approval process one more time for DOB and FDNY.
This one?
FDNY won't do it for you. Yes, yes, I think that's it. Okay. I think that, and the last question is, has the DOB provided any rationale for the other non-combustible materials that were excluded or not cited?
There was a discussion that I had with a couple people from the technical affairs office that were involved in this, that the conversation was, we don't necessarily feel comfortable with the different formulations out there. Now, those aren't my words, and I think that that might be a misunderstanding of the testing requirement for combustibility. But those were the words that were said.
Okay. Yeah, I think that covers it. Salmata, you're still on the line? And so I want to be respectful for everyone's time. So Stephen, thank you very much for the clear
Absolutely.
explanation and the patience to answer all these questions. For all the participants, thank you so much for delving into this somewhat thorny issue. I guess we can adjourn, and please look for this talk on the AIA Building Science website and join us for the next public event.
Thank you.